So we take a look at number 11. It says, which could represent a cubic function with two distinct real roots, meaning two x-intercepts. So if it's talking about roots, if it's talking about zeros, that really means x-intercepts, okay? Well, one way to narrow it down is we're looking for a graph that has two x-intercepts. D only has one x-intercept, so our answer cannot be D, okay? But then we have to look at our remaining graphs and figure out, well, which one's representing a cubic? And we know a cubic has a degree of 3. So the cubic degree equals 3. Okay? Well, the graph of the cubic, if the degree is 3, that means the graph has 2 turning points. So looking at our options, the only graph that has 2 turning points is A. B has 1, 2, 3 turning points. A only has 1. So C only has 1. C is a quadratic because it has 1 turning point. B is a quartic because it has 3 turning points. So that means A is my cubic, and it crosses the x-axis twice. Okay. We take a look at the next one. It says a certain 7th degree polynomial function can be factored as x plus 2 squared times x squared plus 1 times x minus 5 cubed. How many unique x-intercepts does this function have? Okay. There's 2 ways of going about getting this answer. I'll show you the long-handed way. Then I'll show you the shortcut way using your calculator. So the long-handed way would be to take each parenthesis, ignore the exponent on the outside. So take whatever's inside each parenthesis. So x plus 2, x squared plus 1, and I'll write it over here, x minus 5. Take each of those parentheses, again, ignore the exponent on the outside. If it has an exponent on the inside, you want to keep it. And then solve each of those equations. So take what's on the inside, set it equal to 0, and solve each of them. So when I solve here, I move the 5 over, so x is equal to 5. I solve here, I subtract the 2 to get x by itself. I get x is equal to negative 2. And then I solve here to get x by itself. I'm going to subtract the 1. So x squared equals negative 1. And then I'm going to square root both sides. So I have to get rid of that square. The opposite of squaring is square rooting. So I get x is equal to, I took the square root, so I have to put my plus or minus sign. And the square root of negative 1 is up. Okay. So those are my 3 solutions. We want to know how many x-intercepts this guy has, this graph. Okay? Well, in order to be an x-intercept, you have to be a real number. 5 is a real number. Negative 2 is a real number. But I is not a real number. Okay? So, based off how many real numbers we only have 1, 2 x-intercepts. So our answer is A. It's really tempting to add all the exponents on the outside, 2 plus 1 plus 3, to get 6. And that's not even an option. But the degree is equal to the number of roots. Just because it's a root doesn't necessarily mean it's an x-intercept. It could be imaginary. So you're going to look for the ones that have real solutions. We had 2 answers that were real. That means we have 2 x-intercepts. Okay. A shortcut to this would have been just to plug the entire thing into your calculator. Okay. We're going to go to our calculator and type it in. Go to y equals, and we're going to type in x plus 2 squared. And then times x squared plus 1 times x minus 5 cubed. Right? And then hit graph. And we hit graph, you can see that the graph touches the x-axis twice. So that means it has 2 x-intercepts. So this way is much easier than the long-handed way. I just wanted to show you the long-handed way. just in case your calculator malfunctions or you don't have one. But if you just graph it in your calculator, it tells you right there how many x-intercepts it has. It has 2. Moving on to the next one. Number 13. 13 is the same exact type of question. It says, how many times does x cubed plus 8 cross the x-axis? Well, just use your calculator. Go to your calculator, go to y equals, and plug it in. Plug in x cubed plus 8. As you can see, it touches the x-axis 1 time. Therefore, it has 1 x-intercept. So our answer is B. We take a look at 14. It says, is x minus 1 a factor of 4x cubed minus 2x squared plus x minus 3? And so again, there's multiple ways you can go about solving this one, but I think the quickest and easiest way is just using synthetic division. Because if synthetic division works, if we get a remainder of 0, then it is a factor. But if we get a remainder that's not 0, then it's not a factor. So when you use synthetic division, okay, you flip the sign of that number, because essentially what we're doing, we're going to do 4x cubed minus 2x squared plus x minus 3 divided by x minus 1. That's what we're doing. We're going to see if x minus 1 can divide into that polynomial evenly. Meaning we got a remainder of 0. So we use synthetic division. Flip the sign of that number in the second parenthesis. So it's x minus 1. So when we flip it, it's going to become positive 1. And then you're going to write the coefficients of the number in the first parenthesis. Check your exponents. We went 3, 2, 1, nothing. We went in order. Okay, we didn't skip any powers. So we're going to go ahead and write those exponents, or the coefficients. So 4, then negative 2, the coefficient there is 1, and then negative 3. And then we're going to use synthetic division. So we're going to bring down the 4, and then multiply. 1 times 4 is 4. Combine the next two, so negative 2 and 4, when we combine them, gives us 2. 1 times 2 is 2. Combine to get 3. 1 times 3 is 3. Combine to get 0. We have a remainder of 0. Okay. So yes, this is a factor. If we did not get a remainder of 0, then it would not be a factor. And there you go. Those are all your multiple choice questions.